today's video of how particles can bond together through ionic bonds. First I just want to recap what ions are. We said in our previous video that ions are formed when atoms lose or gain electrons. They achieve the stable electronic structure of a noble gas, in other words, a full outer shell. Looking at the periodic table, we can see that metals are on the left-hand side, the non-metals are found on the right. Lots of reactions in chemistry involve a metal reacting with a non-metal. When a metal and non-metal react, ionic bonding takes place. And explain this, we'll take a look at some dot and cross diagrams. Let's start by looking at ionic bonding between the group 1 metal sodium and the group 7 non-metal chlorine. Now I'm using dots to show the electrons on the sodium atom. Sodium, as you can see, our sodium atom has 11 electrons. There are 2 electrons in the first shell, 8 electrons in the second shell, and then 1 electron in the outer shell. And remember that electrons have a negative charge. Sodium atoms also have 11 positive protons in the nucleus. Because there are the same number of protons and electrons, the charges cancel, so an atom of sodium has no overall charge. Here's an atom of chlorine. Chlorine atom has 17 electrons, and crosses to show the electrons on the chlorine atom, but remember that all of the electrons are the same, whether they are shown by dots or by cross. There are 2 electrons in the first shell, 8 electrons in the second shell, and then 7 electrons in the outer shell. Chlorine atoms also have 17 positive protons in the nucleus. Because there are the same numbers of protons and electrons, the charges cancel, so an atom of chlorine has no overall charge. We can see that neither sodium nor chlorine has a full outer shell. When we react sodium with chlorine, the sodium atom loses its outer electron, and this electron is gained by the chlorine atom like this. Now both sodium atom and the chlorine atom have full outer shells. Looking again at the sodium atom, we can see that it still contains 11 positive protons. However, now the sodium atom only has 10 negative electrons. This means that sodium now has an overall 1 positive charge. We now call this a sodium ion, and an ion is an atom with an overall charge. The chlorine atom still contains 17 positive protons. However, the chlorine atom now has 18 negative electrons. This means that chlorine now has an overall 1 negative charge. We now call this a chloride ion. Both sodium ion and the chlorine ion now have a full outer shell. Draw an electron diagram of sodium and chloride ions. The cations are usually drawn to the left of the anions. So, we put big square brackets around them and their charge in the top right corner. The important that here is that the 2 ions have opposite charges, so they will be attracted to each other by electrostatic forces to form an ionic compound. We call this force an ionic bond, and it's really strong. So remember that, during ionic bonding, group 1 metals lose 1 electron, forming a 1 positive ion, and groups of non-metals gain 1 electron, forming a 1 negative ion. Both ions now have a full outer shell. In other words, the stable electronic structure of a group 0, noble gas. Another example is the reaction between the group 2 metal, magnesium, and the group 6 non-metal, oxygen. The magnesium atom has 2 electrons, and its outer shell. The oxygen atom has 6 electrons in its outer shell. Now when magnesium reacts with oxygen, the magnesium atom loses the 2 electrons, and these 2 electrons are transferred to the oxygen atom. As you can see, both the magnesium ion and the oxide ion have a full outer shell. They've achieved a stable electronic structure of a group 0, noble gas. Now we can also show this reaction using a dot and cross diagram like this. Remember that in a dot and cross diagram we only show the outer shells. Let's consider a harder example. Draw the dots and cross diagram. For the formation of magnesium chloride, only draw the outermost shells. Now this time we can see that we have 3 atoms in a compound rather than 2. To start, let's draw out our reactants. We have magnesium, which has 2 electrons in its outer shell, and it wants to get rid of. And we have 2 chlorines, both of which have 7 outer electrons, so we need 1 more each. The next step is to think about where the electrons could move to make all electrons happy with a full outer shell. As a general rule, electron will move from the metal to the non-metal, so in this case magnesium can give 1 electron to each of the 2 chlorines. As a result, we will end up with a magnesium 2+ ion, and 2 chloride 1- ions. This is now pretty much done, however in dotted cross diagrams involving more than 2 ions, we generally arrange the ion like they would be arranged in a real compound. Because the chlorides will both be attracted to the positive magnesium, place them on either side of it. Names and formula of common ions. Tables give the names of some common ions with their formulae. Refer to tables. You should pay special attention to the following points. 1. All simple metal ions, for example sodium and copper ions, are cations. 2. All simple non-metal ions, except hydrogen ion, and most polyatomic ions, for example hydroxide, are anions. There is only one common polyatomic cation, ammonium ion. Simple anions have names ending in IDE, for example a chlorine atom forms a chloride ion, and an oxygen atom forms an oxide ion. Transition metals are rather unusual. The same metal can form more than one simple cation with different charges. To name each ion, a Roman numeral indicating the charge is written in brackets after the name of the metal. For example, copper metal can form copper 1 ion and copper 2 ion. Polyatomic anions containing oxygen often have names ending in ATE or ITE. The polyatomic anion with more oxygen is named as ATE, and that with less oxygen as ITE. For example, sulfate ion, sulfite ion, nitrate ion, nitrite ion.